So Netography's architecture is a system that allows you to deploy capability across your entire atomized network in the cloud and IT and OT environments to give you one view of the composite of your environments. It doesn't care about encryption. It's not affected by it. It works the same whether or not encryption is present. And it's where you need it when you need it, because once again, there's nothing to deploy. We have a cloud-based backend. All it does is accept data from the data sources that we interoperate with, which are primarily flow sources such as switches, routers, firewalls, and load balancers in the on-premise IT and OT worlds, as well as all the major cloud providers, stitches all that information together and then gives you a view of the activities of the infrastructure that's in your environment, once again, without having to deploy anything to make it work. And it also has the ability to aggregate context from those environments together. So we accept context from EDR platforms such as CrowdStrike, from configuration management platforms like Accionis, IPAMs such as Infoblox, as well as VPC context coming out of cloud environments to let you understand the composition of the devices and the members of the infrastructure in your environment, and then apply that information to the communications that we see occurring in those environments, and then run them through real-time detection models so that we can find activities in your environment that may reflect poor operational governance. So devices that are active in the environment that shouldn't be, that are performing activities that they shouldn't be. For example, something like Bitcoin mining, or going to TikTok when you've banned TikTok, or even other activities such as your development environment and your production environment talking to each other in the cloud, which is typically a compliance no-no. These governance activities reflect kind of poor hygiene in the environment, which really is something that's very difficult to see with other scan and report technologies such as CSPM, vulnerability management systems, and attack surface management. At the same time, we're also capable of just basically mapping the environments that we're operating within to let users understand what they have, what it's doing, and what's happening to it. We're also capable of doing compromise detection, so we can detect devices that have changed their behaviors, that have been compromised in the environment, or that are operating in ways that are contrary to, that are essentially known bad behaviors. And then we can provide very rapid access to be able to mine through absolutely massive data sets to threat hunt in the environments to figure out what's happened so that it can be remediated. This real-time detection platform that we have is contrasted by most of the platforms that are out there that are store and query systems. Many of the systems that have been deployed to do similar type things are generally data lakes where you stuff all sorts of information, then you try to weave together a picture by doing these unstructured queries into the data sets. And we know these systems to be slow while having a high degree of flexibility, but unfortunately, because they are so slow, they're very poorly suited to be able to do active threat hunting in many cases. The other interesting thing about our approach is that because it's a real-time engine, it enables real-time response. We can talk via APIs to essentially almost anything, whether we're talking to EDR systems, to quarantine devices that have been seen to be operating in ways that are outside of our compliance or that are obviously bad, talking to firewalls and routing infrastructure to deny access, or simply sending messages to chat ops environments such as Slack or Microsoft Teams, or being able to interoperate with cloud services like NS1 or Route 53 to be able to interdict people using DNS in unacceptable ways. So there are a number of options that are available to us, and our APIs are fully extensible and fully documented so that we can continue to integrate with SIEM, SOAR, such as things like Splunk or QRadar, and all the other platforms that are out there that are wired to do interoperability today. So that is what Netography is doing, and is a very, very high scale system. We are capable of accepting tens of billions of flows per month, reaching into hundreds of billions of flows per month into our system, contextualizing that data, running it through real-time detection models, and being able to respond to what we see in the environment.